Okay, so we have seen how to factor trinomials where we have a leading coefficient of 1, something that looks like this. X squared plus 7x plus 12. And we said the way that we do this is we're going to create two binomial factors. We know they're both going to start with x, and we think of two numbers that multiply to give us 12 and add to give us 7. Well, if we think of factors of 12, I'm going to come over here. 1 and 12, 2 and 6, 3 and 4. 3 and 4 works, so we have x plus 3, x plus 4. This process works when we have a leading coefficient of 1, when there's a 1 in front of my x squared term. We're going to have to use a different process when we have a leading coefficient that's not 1, where my a value is greater than 1. So you'll hear this called a couple different names. We're going to factor it using the AC method. I usually just call it factor by grouping, which we have seen before. And we have to use this anytime our coefficient of x squared is not 1. Whenever we have a number in front of our x squared that's not 1, and we cannot take it out using a greatest common factor. So our problems today will look something like this. 3x squared plus 11x plus 6. We have a leading coefficient in front of our x squared, and we cannot take it out. We can't divide everything by 3 evenly. So if that's the case, we're going to use what we either call the AC method or factor by grouping. And we're going to do that, and I'll read what we're going to do, and I'll read the steps, and then I'll show you how to do it. We're going to split the middle term. When I say middle term, I mean this thing right here. And then we're going to factor by grouping, which we have seen before. Okay, so here's our steps to do this. I'm going to talk about each step as we do our first example, example 294. So our first step is we're going to multiply A times C, our A value times our C value. So 3 times 6 gives me 18. I'm going to write it over here. Our second step says we're going to find two numbers or two factors that multiply to give me AC and add to give me B. So multiply to give me 18, add to give me 11. Let's list the factors of 18. It needs to be a positive 18 and add to be a positive, so it's two positive numbers. So 1 and 18, 2 and 9, 3 and 6. Well, add to give me 11 is 2 and 9. Okay, this third step is what I mean by we're going to split the middle term. So we're going to rewrite this quadratic, but instead of 11x, we're going to rewrite it with 4 terms using the numbers that we just found. So I'm going to write this as 3x squared. I'm going to split this 11x into 2x and 9x, and I'm getting those numbers from right over here. Those are the numbers that we came up with. Plus 6. Okay, so I want you to notice here, we did not change the value. We did not change what this expression is equivalent to. All we did was we rewrote 11x as 2x plus 9x. And the reason we did that is now our last step is to factor by grouping. This is what we have seen before. So to factor by grouping, we're going to group up our first two, group up our last two, and we're looking for greatest common factors. For my first pair, I can only take out an x or a 1x. You can write it either way. If we take that out, I'm left with 3x plus 2. For my next group, 9x plus 6, I can take out a positive 3. If I divide each piece, let me change the color there. If I divide each piece by 3, I'm left with 3x plus 2. The way that we know we did this correctly, this binomial should match this binomial. Since they have it in common, we can factor out a 3x plus 2, and I'm left with x plus 3. So we can try that process again with example 295. We have 8x squared minus 2x minus 15. Again, we notice that there's a number in front of my x squared that we can't factor out. We can't take it out. So we're going to use our AC method, or factor by grouping method. We're going to multiply 8 times negative 15. And hold on, let me get my cheat sheet in front of me. It's going to give me negative 120. So we have to think of two numbers that multiply to give me negative 120 and add to give me negative 2. Well, we could go through and list our factors, but we're going to end up with a negative 12 and a positive 10. We know we need one positive, one negative, and we know our negative 1 needs to be a little bit bigger. So if we rewrite this, splitting that middle term into two terms, I'm going to have 8x squared minus 12x plus 10x minus 15. And the order that we write these two terms does not matter. We could have put plus 10x minus 12x. It's just going to make our next step look a little bit different, but our final answer will be the same. So once we have it as four terms, we can factor by grouping, group up our first two, group up our last two, and look for our greatest common factors. For the first one, we can take out a 4x. If we take out a 4x, we're left with 2x minus 3. And for our second one, we can take out a positive 5. If we divide both pieces by a positive 5, we're left with 2x minus 3. We've got our binomial that's matching, so we can factor that out now. We have a 2x minus 3. If we factor that out, we're left with 4x plus 5. We could check our answers by redistributing back out, but those two binomial factors are our answer. This quadratic is fully factored. Okay, same process on 296. We have a 10 in front of my x squared that we cannot take out. There's no greatest common factor we can take out. So we're going to multiply 10 times 5 and get 50. And we need two numbers that multiply to give me 50, add to give me negative 27. Notice since it has to multiply to be a positive number, add to be a negative number, we need two negative numbers. So if we start thinking through our factors, negative 1, negative 50, negative 2, negative 25, whoop, that one will work so we don't have to keep going. So we're going to rewrite this splitting up that middle term. We're going to rewrite this with four terms. We have 10x squared minus 2x minus 25x plus 5. Again, the order of those two terms does not matter. All right, let's group up our first two. Let's group up our second two and look for greatest common factor. I can take out a 2x on the first one, and I'm left with 5x minus 1. 2x divided by 2x is 1. On the second one, I can take out a negative 5. If I divide both pieces by negative 5, I end up with 5x minus 1. Again, we know we did this correctly because this matches this. So I factor out the 5x minus 1. When I do that, I'm left with 2x minus 5. Okay, on example 297, similar process, but notice we have x's and y's here. All that means is, let me kind of go ahead and write like what our final answer will look like with our two binomials. All that's going to mean is we're going to have an x with my first terms. We're going to have a y with my second terms here. All right, so let's go ahead and multiply our a times our c. We can't take out that 4, so we're going to multiply 4 times negative 5, and we're going to get negative 20. We want to think of two numbers that multiply to give me negative 20 and add to give me a negative 1. Those are going to be a negative 5 and a positive 4. Okay, so we're going to split our middle term using those two numbers. So I'm going to have 4x squared minus 5xy, notice this is xy, plus 4xy minus 5y squared. All right, let's continue factor by grouping. Group up our first two, group up our last two. For our first two, I can only take out a 1 for my numbers, and really I can only take out an x for my variables. So I end up with 4x minus 5y. Okay, for our second one, pretty much the same, except I can only take out a y, a positive y. I'm left with 4x minus 5y. So notice here, you can kind of see how it ended up. Let me erase this real quick. We have 4x minus 5y as our binomial common factor. I'm going to take that out. 4x minus 5y. When we do that, I'm left with x plus y as my other binomial factor. So it doesn't matter if it has multiple variables in there, we still do the same way. We can call it the AC method or the factor by grouping method. Okay, on example 298, notice here we do have a number greater than 1 in front of our leading term, but we do have a greatest common factor we can take out. So if we look at all of these, let's start with our numbers, with our coefficients. We can divide all of those by 3, so we take out a 3. And then we can actually take an x out of all of these. They contain at least one x. I'm going to take a 3x out of all these. If we do that, I'm left with 6x squared plus 11x minus 10. Okay, so now look what we have inside our parentheses there. Now this looks like the problems that we have been doing. So we're going to continue the same way. We're just going to leave that 3x hanging out in front. I'm going to multiply this 6 by the negative 10. We get negative 60. Two numbers that multiply to give me negative 60, add to give me 11. We know we need one positive, one negative. Well, if we think through our factors, we're going to end up with a positive 15 and a negative 4. So we can rewrite this. I'm just going to leave this 3x tagging along out in front. And I'm going to rewrite this as 6x squared plus 15x minus 4x minus 10. Okay, we're still going to group the same. Group our first two. Group our last two. I'm going to leave that 3x tagging along out in front. For my first ones, I can take out a 3x. If I do that, I'm left with 2x plus 5. Here I can take out a negative 2. If I divide both pieces by negative 2, I get 2x plus 5. Okay, so let's see what our final answer is going to look like. I know this looks a little bit messy. We just have our 3x out in front. Then we're going to have our two other binomial factors. Our matching greatest common factor binomial is this 2x plus 5. If we take that out, we're left with 3x minus 2. So the process is still the same, even if we have to take a greatest common factor out first. It just looks a little bit messier, and we just leave our greatest common factor out in front the whole way through the problem. All right, and then our last one here, we have 3x squared plus 2x minus 7. We have a 3 in front of our x squared term that we cannot take out. There's no greatest common factor besides 1. So we multiply our a times our c, and we want to think of two numbers that multiply to give me negative 21, add to give me 2. Well, we know we need one positive, one negative. We need our positive number to be bigger, so we can have negative 1 and 21, negative 3 and 7, and that's all. And if you notice here, neither one of these options are going to add to give me positive 2. So factoring this is actually impossible. You cannot factor. Or we could say that this is prime. Prime means that it cannot be factored. So sometimes we'll encounter some where there just is no possible way to factor it. So we just leave it alone. We can call it prime.